Alright, in this video we're looking at some problems from our organic chemistry worksheets, specifically the worksheet booklet on alkanes and cycloalkanes. This is question number 8. We're going to name some molecules, and then in a moment we'll reverse it and we'll draw some molecules. And we're going to use the UPAC rules for naming. In this question 8, in addition to writing the UPAC name, we also want to write down the molecular formula of the alkane. Recall that for an alkane, a hydrocarbon with just carbon-carbon single bonds, the generic formula of the alkane is CnH2n plus 2. So if you have 5 carbons, you would have 2 times 5 plus 2, you'd have 12 hydrogens in the formula. All right? So in this first molecule, you remember you first start by identifying the parent chain, the longest continuous chain, and in this case it'll be 1, 2, 3, 4, 5 carbons. This is an example of a bond line formula. Each line here represents a bond between carbon atoms, so these vertices are carbon atoms. The carbon atoms at the end of the chain are shown, but you have to imagine there's carbons where you see a vertex like that. So 1, 2, 3, 4, 5 carbons means the parent chain is pentane, and then we see there's a branch with only 1 carbon in it. A 1-carbon branch is called methyl, and in this case, numbering from the end of the parent chain closest to the branch, it would be on the 2nd carbon in the parent chain. So you always number the parent chain closest to the branch. So in this case, the name would be 2-methylpentane. And technically, methylpentane would be all one word. Part B, again, find the parent chain. So in this case, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So 6 is the longest continuous chain, so it's going to be a hexane. Now, which end of the parent chain should we number from so we can name the branches? If we number from the left, it would be carbon 1, 2, 3, and 4. Carbons 3 and 4 would have the branches. If we number from the other end, it would be 1, 2, 3, and 4. 3 and 4 would have the branches. So it doesn't really matter in this case which end we number from. This could be carbon 1, carbon 2, carbon 3, carbon 4, 5, 6. So carbon 3 and 4 have branches. The branches are each methyl branches, 1-carbon branches. But there's 2 of them. If you've got more than 1 of a branch, you put a prefix in front. So we're going to call this 3,4 dash dimethyl, because there are 2 methyl branches. And then the parent was hexane, 6 carbons. Okay, so break that name down again. The parent, 6 carbons, was hexane. There were 2 methyl branches, so dimethyl. The branches are found in carbons 3 and 4 in the parent chain, so 3,4 dimethylhexane. The next example. The parent chain has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 6 carbons again in the parent chain. Now, in terms of numbering, we notice that one of the branches is a methyl branch, but the other branch has 2 carbons. It's going to be an ethyl branch, okay, with 2 carbons, 1 carbon, 2 carbons. So we're going to name the ethyl branch before the methyl branch. Remember that, alphabetically. Ethyl before methyl. Now what about the numbering of the parent chain? If we number from the left, 1, 2, 3, 4, 5, 6, carbon 3 and carbon 4 will have the branches. If we number from the right, 1, 2, 3, 4, 5, 6, it's still carbon 3 and 4 that have the branches. So in a way, it's kind of like the one before. You might think it doesn't matter. In fact, I'd be okay in this case, whichever way you number it. But technically, because we're going to name the ethyl branch before the methyl branch, I'm going to start numbering from the right-hand side, and I'll call this carbon 1, carbon 2, carbon 3, so the ethyl branch will have the lower number, carbon 4, carbon 5, carbon 6. If you were to number it the other way around, that would be fine. So the way I've numbered it, naming the ethyl branch first, I'm going to say 3-ethyl, because the ethyl branch was attached to carbon number 3 in the parent chain, dash 4-methyl, because the methyl branch, the 1-carbon branch, is on the 4th carbon in the parent chain, and then the parent chain itself had 6 carbons, so hexane will be the parent root name. 3-ethyl, carbon number 3, there's an ethyl branch, a 2-carbon branch. 4-methyl, carbon number 4, there's a single carbon branch, a methyl branch. And hexane, there's 6 carbons in the parent chain. Part D, the parent chain would be 1, 2, 3, 4 carbons long. So I'll number it 1, doesn't matter which end I number from. If I number it from this end, 1, 2, 3, 4, carbon 2 and carbon 3 have branches. If I number it from the other way, carbon 2 and 3 still have branches, so it doesn't matter in this case. 1, 2, 3, 4 is how I'll number it. And then carbon 2 and 3 have methyl branches on them, single carbon branches. So we're going to call this 2, 3, carbons 2 and 3, dash dimethyl, because there's 2 of the methyl branches, and then 1, 2, 3, 4 carbons, a 4-carbon alkane is butane. So butane is the parent name. 2, 3 dimethyl butane. And now this guy's a little longer looking molecule. The parent chain is 1, 2, 3, 4, 5, 6, 7, 8 carbons long. Now if I number it from the left, the branches, there's 3 methyl branches here. The branches would be on carbon 1, 2, 3, 5, and 6. So if I number it from the left, the branches would be 3, 5, and 6. But if I number it from the right, the branches would be on carbon 1, 2, 3, 4, and 6. 3, 4, and 6. So I want to keep the numbers smaller. So I'm going to number this from the right-hand side. This is carbon 1, carbon 2, 3, 4, 5, 6, 7, 8 in the parent chain. So on carbon 3, carbon 4, and carbon 6, there's methyl branches. That's 3 methyl branches. So 3, 4, 6. 3, the prefix would be tri, so trimethyl. And then 8 carbons in the parent chain. 8, the prefix is octa, so octane is the parent root name for the alkane. So 3, 4, 6, trimethyl octane. There is an 8-carbon parent chain, octane. There are 3 methyl branches, single carbon branches, and they're found on carbons 3, 4, and 6 in the octane parent chain. Question F, the longest continuous chain would be just 4 carbons, carbon 1, 2, 3, 4, and there's no branches. So this really isn't a branched alkane, it's a normal alkane, an unbranched alkane. With 4 carbons, its name is simply butane. Some people would call it normal butane or N-butane, but we can just call it butane. Now I just realized I haven't been putting down the chemical formulas, the molecular formulas of these molecules. We were asked to do that. So we remember the chemical formula of an alkane is CnH2n plus 2. So your number of carbons doubled, and then 2 more is the number of hydrogens. So in butane, there's 4 carbons, so C4, and then to find the H's, you double the 4 and add 2, so H10. Back here in part A, we had 2-methyl pentane. Pentane has 5 carbons. The methyl is a single carbon, so that's C6. Double the 6 and add 2, it'll be C6H14. In the next one, hexane has 6 carbons, but we have 2 methyl branches. The methyls are single carbons, so 6 plus 2, we have 8 carbons, C8, and then we double the 8 and add 2, and we get H18. 3-ethyl 4-methyl hexane. Hexane has 6 carbons, there's a methyl branch with 1 carbon, and there's an ethyl branch with 2 carbons. So 2 plus 1 is 3, plus 6, this is C9, and double that and add 2, H20. Next one, 2,3-dimethyl butane. Butane has 4 carbons. Methyls each have 1 carbon, but it says dimethyl, so we have 2 of those. So 4 plus 2, this is C6 and H14. Okay, notice that that is the same molecular formula as the first one, but they're different molecules. Those are called isomers, right? And isomers are molecules that have the same molecular formula, but different molecular structures. Okay, their atoms are connected in different ways. Part E, octane has 8 carbons. Methyls have 1 carbon, but we have 3 of the methyls. So 8 plus 3, this would be C11. And then H, double this and add 2, H24. All right? A few more. You can pause the video and try these yourself if you like. So the longest continuous chain here would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons. When we number the parent chain, we should number at the end closest to the first branch. So in this case, I'll number from the right, carbon 1, carbon 2, so that the methyl branch is carbon 2. If I numbered from the left, it would be 1, 2, 3, 4. It would be the carbon 4 is where the first branch is found. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. On carbon 2, there's a methyl branch, a 1-carbon branch. On carbon 7, there's a 2-carbon branch, an ethyl branch. So we name the ethyl branch before the methyl branch. This is going to be called 7-ethyl 2-methyl. And then the parent chain was 10 carbons. So decane is a 10-carbon alkane. 10 carbons plus 1 is 11, plus 2 more, this is C13, and H, double this is 26, and add 2 is 28, C13, H28. The next guy, this is again a bond line formula, so we remember there's carbon atoms wherever you see a vertex. So in this case, the longest continuous chain, we're probably going to start up here, 1, 2, 3, 4, 5, 6, 7, or 6, 7. 7 carbons would be the longest chain. When we number that parent chain, should we start up here, or should we start down at one of these guys? Well, if we start at one of these guys, we'll hit a branch earlier than if we started up here. So we always number at the end closest to a branch. So I'll call this carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, 6, and 7. If you wanted to call this carbon 1, carbon 2, carbon 3, that would be just as fine. Okay, those will give you the same name. So in this case, we look and see there's an ethyl branch, 2 carbons, and another ethyl branch, 2 carbons. One is on carbon 3 and one is on carbon 4 in the parent chain. So this will be 3, 4 dash diethyl. There's 2 of those ethyl branches. And then 7 carbons in the parent chain, heptane. 7 carbons plus 2 is 9, plus 2 more, because it's diethyl. This is C11 and H24. And just like earlier, we've seen that molecular formula earlier but it was a different molecular structure. So this molecule and this molecule are structural isomers. Okay? They're isomers. They have the same molecular formula, but they're different molecules. They have different molecular structures. The next one is very simple. It's just 2 carbons. So 2 carbons and no branchings. This is just ethane. A 2-carbon alkane is ethane. This next one looks quite complicated. Let's find the longest continuous chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 9 carbons is the longest chain. Now, if we numbered from the left, there would be branches on carbon, let's see, 1, 2, 3 would have a branch. 4, 5 would have a branch. Let's see, 1, 2, 3, 4, 5. 6 and 7 would have branches also. So 3, 5, 6, and 7, if I were to number from the left. If I number from the right-hand side, 1, 2, 3, 4, and 5, 3, 4, and 5, 6 and 7, so 7, 3, 4, 5, 7. So numbering from the right gives me smaller numbers than if I were to number from the left, so I'm going to number from the right-hand side. Carbon 1, carbon 2, carbon 3, carbon 4, 5, 6, 7, 8, 9. Again, if you wanted to go 7, 8, 9, that would also be fine. So now we look and say there's methyl branch here, and then there's 1, 2, 3 ethyl branches, 2 carbon branches. So we're going to name the ethyl before the methyl, and so we're going to say carbons 4, 5, and 7. So 4, 5, 7. And then, because there's 3 of them, we'll say triethyl. And then on carbon number 3, there was a methyl branch. So 3 methyl. And there were 9 carbons in the parent chain, so nonane or nonane. Now, someone who's paying attention to the alphabetizing, the alphabetical order, might say, but wait a minute. Triethyl starts with a T and methyl starts with an M. Why did we put triethyl first? When you're alphabetizing, you don't pay attention to the prefix. So ethyl before methyl, and then put in the prefixes as you need them. But put the ethyl before the methyl because of the alphabetizing branchings. All right. The chemical formula for these last two. Ethane had 2 carbons, so C2, double that and add 2 more, C2H6. And then this guy here, very complicated looking, but nonane is 9 carbons, the methyl is 1 more, and triethyl, 3 ethyls. Each of the ethyls has 2 carbons. So 3 times 2 is 6, plus 1 is 7, plus 9, this is C16. And then the H's, double that and add 2, H34. Okay? All right. Give a combustion equation, balanced equation, for 2-methylhexane. Well, to figure that out, I need its molecular formula. Hexane would have 6 carbons. 2-methyl, there's 1 more carbon. So this is C7. And then the H's, double that and add 2, would be C7H16. It's a combustion reaction, so we add O2. And when you burn hydrocarbons, no matter what their chemical formula, you always get carbon dioxide and water, assuming it's a complete combustion reaction. To balance this, we have 7 carbons, so we'll put a 7. 16 hydrogens, so we'll put an 8 there. 8 times 2 is 16. 7 times 2 is 14, plus 8 is 22, so I'm going to put 11 in front of the O2. 11 times 2 is 22. All right, so those were mostly given a molecule, give its name. Now, there's a few other examples here with different ways of representing the molecules. We've been looking earlier at bond line formulas. These are the condensed molecular formulas. The same idea, but now instead of those zigzag lines, we have CHs, CH2s, CH3s. It's the same idea. So let's try to provide the UPAC name for these. So you find the longest continuous chain of carbons. So we can start over here, 1, 2, 3, 4, 5, 6, and then 7, 8, 9. That looks to be the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 is the longest chain. So this guy's going to be a no-name. Now when we name it, we want to number the parent chain from the end closest to the branch. If we count from the left, 1, 2, 3, carbon 4 would have a branch. Carbon 5 would have a branch. Carbon 6 would have 2 branches. So I'm going to put 6 and 6 again. So that's if we number from the left. If we number from the right, 1, 2, 3, 4, so carbon 4 would have 2 branches, so I'll put 4 and 4. Carbon 5 and carbon 6 each have branches. So now if we number from the left, we get these numbers. If we number from the right, we get these numbers. Which ones are going to give me smaller numbers? Well, numbering from the right. So I'm going to number from the right and call this 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what are the branches? On carbon 4, I see a methyl branch. There's another methyl branch in carbon 6. On carbon 5, there's a propyl branch. 3 carbons is propane, so as a branch, it's propyl. And on carbon 4, there's a 2-carbon branch, and that's ethyl. So we have ethyl, propyl, and methyl, and we're going to name them alphabetically. So ethyl, and then methyl, and then propyl. So let's name the ethyl first. That's on carbon 4. So 4-ethyl. Now let's name the methyls. There's 2 of them, one on carbon 4 and one on carbon 6. So dash 4, 6, dimethyl. There were 2 of the methyls. Now let's name the propyl. It's on carbon 5, this 3-carbon branch. So dash 5-propyl. And then the parent chain, which had 9 carbons, is no name. Okay. Try the next one. The longest continuous chain of carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, I believe. And now, which end should I number from? Because there are several branches. There's a methyl branch, there's another methyl branch, there's an ethyl branch, and another methyl branch. So I'm going to name, let's see, if we number from the left, 1, 2, 3, 4, 5 would have a branch, so I'll put a 5 here. 6 would have 2 branches, so I'll put 6, 6, and then 7 would have a branch. So that's if I numbered from the left. If I number from the right, 1, 2, 3, 4 would have a methyl branch. Carbon 5 has 2 branches, 5, 5, and then carbon 6 has a branch. So of those 2 choices, the second one looks better with smaller numbers. So I'm going to number from the right. So it'll be, we have methyl branches and we have ethyl branches. So ethyl before methyl. So on carbon 1, 2, 3, 4, 5, there's an ethyl. So 5-ethyl. And then on carbon 4, 5, and 6. Okay, did I get that wrong earlier? 4, no, that's right. 4, 5, and 6. There are 3 methyl branches. So dash 4, 5, 6, and 3 of them. So we'll say trimethyl. And then the parent chain had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. So decane is the parent name. 5-ethyl 4,5,6-trimethyl decane. All right, the next one's a little bit easier. It's a smaller molecule. The parent chain has 1, 2, 3, 4, 5 carbons, and I should number from the right-hand side. It'll be closer to the branches. So carbon 1, 2, 3, 4, 5. The branches each have 1 carbon, so these are all methyl branches. There's 2 of them on carbon 2, and 1 of them on carbon 3. So I'm going to call it 2, 2. Those are the 2 that are on carbon 2, 3, and then 3 methyl branches, so trimethyl, and then 5 carbons in the parent chain, pentane. This next one, the longest continuous chain, 1, 2, 3, 4, 5, 6, 7 carbons. It's clear that we should start from the right-hand side to get to the branches first. If we number from the left, it'll take longer to get to the branches. So number from the end closest to the branches. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. So this is going to be a heptane. On carbon 3, there's methyl branches, 2 of them. On carbon 4, there's another methyl branch. On carbon 4, there's also an ethyl branch, 2 carbons here. So we've got ethyl and methyls. We're going to name the ethyl first. So it's on carbon 4, so 4-ethyl. And then the methyl branches, there's 3 of them. 2 of them on carbon 3, and 1 of them on carbon 4. So dash 3, 3, 4, 2 of them on carbon 3, 1 of them on carbon 4, 3 of them, so trimethyl. And then the 7 carbon parent chain, heptane. So 4-ethyl 3,3,4 trimethyl heptane. And one more of these. So this guy's got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 carbons is the parent chain. There's a couple of ways we could get the 5 carbons. If I go 1, 2, 3, 4, 5, then there will be methyl branches and ethyl branches. But if I went 1, 2, 3, 4, 5, there would be a methyl branch and then a weird branch here. Weird because the branch would be attached not by the end carbon but by a middle carbon. And there is a way to name that. It's called isopropyl, but I don't want to do that. So I'm going to number the parent chain like 1, 2, 3, 4, 5. I'll not go down here. Okay? Now which end should I number from? I'll number from the right-hand side to get closest to a branch. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So on carbon 2 and 3, there's methyl branches, and on carbon 3, there's an ethyl branch. So ethyl before methyl, alphabetically. This will be 3-ethyl, and then 2, 3, dimethyl, 2 of them, and 5 carbons, pentane. All right, so I hope that helps with, given a molecule structure, deducing its UPAC name for branched alkanes. We saw several different representations. The condensed formulas is what we're looking at here. We saw pure bond line formulas, and then sort of a hybrid bond line formulas with the carbon showing at the end. All right, so I'm going to do a separate video for the reverse, where you're given a name and try to figure out the molecular structure.